This video is about Rolle's theorem, and before we go over all the conditions, let me just explain what he wants us to know. So if you have 2 points here, and these points are exactly the same height, so we have some f of a and some f of b, because we're going to plug in a and we're going to plug in b, so we get those two function values, those y values. If our f of a and f of a is equal to f of b, then the only way to connect it is either by going straight across, by going up, or going down. Now you can combine these and go straight across and then up and then down, but it's going to include these three together. So what that means is if you have these 2 points and you connect them continuously, well, you're going to have to create a derivative that equals 0. So this is a straight line. So every single point you plug in is going to have a derivative of 0. It's a horizontal line, sorry. All lines are straight. And then this point right here, you could see that our f prime of c would equal 0. And then this point too, our f prime of c equals 0. So if that's the situation that these two are equal, you go straight across, you're going to get a derivative equal to 0. Then we've got a theorem going. So if f is continuous on the closed interval, so we have a closed interval from a to b, right? And it's continuous. These three situations would happen. If f is differentiable on that interval, so we can find the derivative on this interval, that's needed, and f of a equals f of b, if these three are met, then there is some number c such that f prime of c is equal to 0. So long story short is you have 2 points. If you connect those 2 points, their slope would be 0. So if I took the slope of this point with this point, they both have the same y value. So their slope would be 0. So that means coming in here, there has to be some other point that equals 0 right there. So I do have another c value that if I plugged into the derivative, it would also be 0. That's all Rolle's thing. So if we have 2 points, they both have the same y value, it's a continuous function, all points are differentiable on it, well, then you're going to get another derivative in there that is equal to 0. So let's try one to prove what's going on here, sort of. So we're going to find 2 x-intercepts. This is one way that we can do this. If you find 2 x-intercepts, so if we set this equal to 0, let's do this in blue. So if we make our f of x equal to 0, that means our y is 0. Then we get x squared minus 3x. Then we would get 0 equals x, x minus 3, x equals 0, x equals 3. So we would have 2 x-intercepts, one at 0, 0, and one at 3, 0. Well, if we know that we have 2 x-intercepts, one at 0 and one at 3, and we have a polynomial that is continuous on this closed interval, so we know it's continuous on 0, 3. It's differentiable because it's a polynomial on 0, 3. And then number 3, we know that f of 0 is equal to f of 3 is equal to 0. So the f of a and f of b are the same. That means these three together, that we must have some f prime of c that is equal to 0. And you can see it clearly, it's right here. There has to be some derivative. So if you have some polynomial and you have 2 x-intercepts, you know that there has to be some derivative equal to 0, some critical number in there between these two. So it's a way to use it. So if you found 2 x-intercepts, there's a critical number. So show that f prime of x is equal to 0 at some point between the x-intercepts. So now if we take our derivative, you get 2x minus 3. And so now we can say f prime of c is equal to 0. Add the 3. So we get a c equals 3/2. So we just showed that f prime of 3/2 equals 0. And there it is. There's the 1.5. So right there, our c equals 3/2. And our f prime of c is equal to 0. That's all Rolle's theorem is stating. So one way to use it is that if you have 2 x-intercepts, you know there's a critical number in between if the function's continuous on that interval. All right, so let's do another one, very similar. So let f of x equal this. Find all values of c in -2 to 2 such that f prime of c is equal to 0. and draw a picture to show Rolle's theorem. So we have -2 and 2. So if I plug in -2, sorry, I should have written the function first, x. So if I plug in -2 into this function, we get 8. And so now if I plug in 2, we get 8. So you can see that part C is already met. So if we look at number 1, so it says for number 1, again, to go back, f is continuous on the interval. It's a polynomial. So f is continuous on -2 to 2. Number 2, it's a polynomial, so f is differentiable on -2 to 2. Oops, parenthesis. And then number 3, f of -2 is equal to f of 2. They both equal 8. So all 3 conditions are met. Therefore, there must be some derivative with c equal to 0. And we can have multiple points on it. So now we're going to find all of those values. We've shown with Rolle's theorem that there has to be some values. And why is that? Well, because, again, this one is equal to this one, and it's continuous. So let's try f prime of x. This is equal to 4x cubed minus 4x. And I like to change it to a c. Equals 0. We factor out the 4c, and we end up with c squared minus 1. So we get 4c, c minus 1, c plus 1. And so we get c equals 0, c equals 1, and c equals -1. And so that would be here, here, and here, just like on our picture. So there's our c values. So for any of these, f prime of c is equal to 0. And there you have it. So long story short, if you find 2 y values and your function is continuous, according to Rolle's theorem, guess what? 2 y values that are equal. According to Rolle's theorem, there has to be some critical number within those 2 points, as long as these 3 are met.